Hi students, good morning. In the last class, we have discussed some objective problems. Okay, in this session also, we are continuing some other problems related to binomial theorem. Okay, in this session, we are going to discussing the infinite series and approximate values. Okay, let us start now. See the problem. The quotient of x to the power of 49 in x minus 1, x minus 2, x minus 3 and so on, x minus 50. So we have to find the quotient of x power 49 in that expansion. Okay, see the solution. So this is the expression. Given expression is x minus 1 into x minus 2 into x minus 3 and so on, x minus 15. In that, what is the quotient of x to the power of 49? So using this formula, the quotient of x to the power of n minus 1 in x minus alpha 1, x minus alpha 2 and so on, x minus alpha n is sigma alpha. So here alpha, that is alpha, or r is 1 to n. So using this formula, we are finding the quotient of now we are writing the quotient of x to the power of 49 in the given expression is sigma what is the alpha is here 50, that is what is alpha I is 1 to 50, that is sigma sum of n natural numbers, that is 50 natural numbers, that is minus n into n plus 1 by 2, that is 225 are. Okay, that is 25 into 51. Okay, that is minus of okay, minus 1 to 75. So this is the value of the quotient of x to the power of 49 in the expression x minus 1 into x minus 2 into x minus 3 and so on, x minus 15. Okay, see the problem. The quotient of x to the power of 29 in the expansion of x plus 1 into x plus 2, x plus 3 and so on, x plus 30. Okay, this is the problem. See the solution. What is the given expression here? That is x plus 1, x plus 2, x plus 3 and so on, x plus 30. In that expansion, now we have to find the quotient of so here quotient of x to the power of n minus 1 in the expansion of x plus alpha 1, x plus alpha 2 and so on, x plus alpha n is the formula sigma alpha I. Okay, so in that we have to find the quotient of x to the power of 29. Therefore, the quotient of x to the power of 29 in the given expression is equal to, what is here formula, that is sigma what is alpha I here, I is 1 to 30. Okay, that is what is the formula, n into n plus 1 by 2. Here n is 30 into 31 by 2, that is 2 15s, 15 into 31, that is 465. Okay, so this is the quotient of x to the power of 29 in the expansion of x plus 1 into x plus 2, x plus 3 and so on, x plus 30. Okay, see the problem. The sum of the coefficients of odd powers of x in the expansion of 1 plus x minus x square minus x cube whole power 6. Now I have to find the sum of the odd powers of x. See the solution. So what is the formula here? Given expression is that is 1 plus x minus x square minus x cube whole to the power of 6. In that expansion, we have to find the sum of the odd powers of x. The sum of the odd powers of x is equal to, the formula is f of 1 minus f of minus 1 by 2. What is here f of 1? That is, this is the function. In that function, we have to substitute in place of x is 1. 1 plus 1 minus 1 whole power 6. That is 0. Here f of minus 1, that is, we have to substitute in the place of x is here minus 1. That is 1 minus 1. Here minus 1 whole square is plus 1. Here minus 1 whole cube is minus of minus plus 1 whole power 6. Here also this will be cancelled 0. Here f of 1 is 0 and f of minus 1 is 0. Now substitute in this, we are getting that is 0. So the value of sum of the odd powers of x is 0. See the problem? The sum of the last 20 coefficients in the expansion of 1 plus x whole power 30 when expanded in ascending powers of x. Okay, so that is the problem. See the solution. So what is the given expression here? That is 1 plus x whole power 39. So this is the given expression. In that expansion, so the sum of the last 20 coefficients, sum of the last 20 coefficients, the sum of the last 20 coefficients, let it be yes. Okay, let it be yes, is equal to, okay, what is the coefficients last 20? That is 39, C20, 39, C21 and so on, 39, C39. These are the last 20 coefficients in the expansion of 1 plus x whole power 39. So now we have to write the sum of these coefficients. Now we are taken this s is, now we are applying the formula. So what is the formula? NCR is equal to NC n minus R. Using this formula, we are writing the coefficients here. 39C, 39 minus 20, that is 19. Here 39C, here 39 minus 21, that is 18 and so on. 39C, 39 minus 39 is 0. Now adding these two, that is s plus s is equal to, now we are writing from this last two. Okay, so that is 39 C0, 39 C1 and so on. Here 39 C19. Okay, up to this. Okay, next we are writing these values, that is 39 C20, 39 C21 and so on, 39 C39. So these are all sum of all binomial coefficients in this expansion of 1 plus x whole power 39. These are all sum of the binomial coefficients. What is the sum of the binomial coefficients formula? That is sum of the coefficients C0 plus C1, C2 and so on. Cn is equal to 2 to the power of n. This is the formula. So here what is n? N is here 39. 2 to the power of 39. So this is 2s. 2s is equal to 2 to the power of 39. Therefore, s is equal to 2 to the power of 39 by 2. That is 38. So the sum of last 20 coefficients in this expansion 1 plus x whole power 39 is 2 to the power of 38. That is the answer. Okay. See the problem. If TR denotes the rth term in the expansion of 1 plus x plus 1 by y whole to the power of 23. In that expansion, TR denotes the rth term in the expansion. Okay. Now we are write the solution. What is the given expression is here? X plus 1 by y. X plus 1 by y whole power 23. Whole power 23. In that expansion, we have to in the options in the multiple options, what is the relation between T12 and T13? So what is T12? That is T12 is T11 plus 1. That is we are writing T23 C11 x power that is 23 minus 11, that is 12 into 1 by y whole to the power of 11, that is T12, that is T12. So that is 23 C11 x power 12 into 1 by y to the power of 11. Okay, now we are writing T13. What is T13? T12 plus 1. So 13 T13. 13th term is T12 plus 1. What is the term here? That is NCR 23 C12 into x to the power of 23 minus 12, that is 11 into 1 by y to the power of 12. Okay, so this is the 13th term. Okay, so this is the 13th term. Now what is the relation between T12 and T13? So we are wanting what is the relation between 12th term and 13th term. So what is here 12th term here? That is T12 is equal to here 23C 11. So this can be written as 23C 23 minus 11. Okay. Here x to the power of 12, that is x to the power of 11 into x. Here we are multiplying y and dividing y to the power of 12. So that is 23C. What is 23 minus 11? That is 12. Here x to the power of 11 by y to the power of 11 into xy. Okay, so from this T12 we are writing this one 23C12 into x power 11 by y power 12. Here we are multiplying and dividing. Here x power 11 by y power 12 into xy. So what is the value of this one? 23C12 into x power 11 by y power 12 is nothing but T13, that is the 13th term into xy. Okay, so what is the relation between these two terms? T12 is equal to xy into T13. So this is the answer. So this is the correct answer. T12 is equal to xy into T13. See the problem. The binomial coefficient which are descending order. In the options, we are to given 15 C7, 15 C6, 15 C5. So like that. So what is the descending order? That is the decreasing order. So here n is what is see the solution. Here n is equal to 15. So in the options we are given 15 C6, 15 C5, 15 C7 like that. So what is the descending order? First we have to find which is the greatest binomial coefficient. What is the greatest binomial coefficient for n is equal to 15? So here which is odd. So if n is odd, the greatest binomial coefficient is NC n minus 1 by 2. NC n minus 1 by 2. So now we are writing that is 5C. What is here? 15C. 15 minus 1 by 2. That is 15C. 14 by 2. That is 7. So which is the greatest binomial coefficient? So what is the descending order? What is the descending order here? Decreasing order or descending order is 15C7, 15C6, 15C5. This is the decreasing order of the in the given multiple choice. Okay, so first we have to find the greatest binomial coefficients. For n is equal to 15, which is odd number. So it is odd number. Therefore, the greatest binomial coefficient is the formula nc n minus 1 by 2. So using this formula here n is 15, 15c 15 minus 1, that is 14 by 2, that is 7. 15c7 is the greatest binomial coefficients. So now we are writing the decreasing order 15c7, 15c6, 15c5 like that. Okay. See the problem. The middle terms in the expansion of x minus 1 by x whole power 15. In that we have to find the middle term. So what is the given expression here? That is x minus 1 by x whole power 15. In that, what are the middle terms? We have to find the middle terms. So here n is 15, which is odd number. So if it is odd number, then what are the middle terms? So there are two middle terms. Therefore, the middle terms are t n plus 1 by 2 and t n plus 3 by 2. These two are the middle terms. So that is here n is 15 plus 1 by 2, t 15 plus 3 by 2. That is t 16 by 2, that is 8, t that is 18, 9. So 19 by 2. So here 18 by 2. So t 15 plus 3, t 18 by 2 is t 9, and here t 16 by 2, that is t 8. These two are the middle terms. These two are the middle terms in the expansion of x minus 1 by x whole power 15. So if n is odd, then the middle terms are t n plus 1 by 2 and t n plus 3 by 2. So there are two middle terms if n is odd. If n is even, then only one middle term, t n by 2 plus 1 is the middle term. Here n is odd, we are getting the two middle terms, t n plus 1 by 2 and t n plus 3 by 2. These two are the middle terms, that is t 8 and t 9. 8th term and 9th terms are middle terms in the given expression. Okay, see the other problem. The coefficient of the middle term in the expansion of 1 plus x whole power 40. So, okay, in that expansion, the coefficient of middle term, I have to find the coefficient of the middle term. Okay, see the solution. So, what is the given expression? 1 plus x whole power 40. In that expansion, we have to find the middle term. What is the middle term? Here, n is 40, which is even. So it is even number. Then what is the middle term? That is middle term is equal to t n by 2 plus 1. That is t 40 by 2 plus 1. That is t 20 plus 1. So what is the term we are writing here? That is t 20 plus 1 is equal to, what is the term here? NCR 40 C 20 into x to the power of 20. Now what is the coefficient here? 40 C 20. So therefore the coefficient of the middle term in given expression is equal to 40 C 20. So this can be written as, what is the 40 NCR formula? 40 factorial by 40 minus 20 factorial into 20 factorial. That is 40 factorial by 20 factorial into 20 factorial. We are simplifying this one. We are getting 1 into 3 into 5 and so on. 39 by 20 factorial into 2 to the power of 20. So after simplification, we are getting the value of 40 factorial by 20 factorial into 20 factorial. We are simplifying. Then we are getting 1 into 3 into 5 and so on. 39 by 20 factorial into 2 to the power of 20. So this is the required answer. Okay. See the problem. The greatest binomial coefficient among the coefficients here 15C0, 15C1, 15C2 and so on, 15C15. So in that we have to find the greatest binomial coefficient. So the given coefficients are 15C0, 15C1, 15C2 and so on 15C15. Here what is n? Here n is 15, which is odd number. So if n is odd number, the greatest binomial coefficient is equal to there are two coefficients are nc n minus 1 by 2, nc n plus 1 by 2. These are the greatest binomial coefficients. So that is here n is 15, 15c 15 minus 1 by 2, 15c 15 plus 1 by 2. So that is 15c 14 by 2, that is 7, 15 that is 16 by 2, that is 8. So these are the greatest binomial coefficients. So what are the binomial coefficients here? 15c7 and 15c8. These two are the greatest binomial coefficients in the given binomial coefficients. 15c0, 15c1, 15c2 and so on, 15c15. Here n is odd number. If n is odd number, there are two greatest binomial coefficients. These are nc n minus 1 by 2 and nc n plus 1 by 2. Okay, we are getting the greatest binomial coefficients 15c7 and 15c8. Okay.